This video we are going to solve a problem based on Coulombs force but without numbers. So here we have got a force F is measured between two charges Q, capital Q and small q, separated by a distance r as shown in the diagram below. Explain what happens to the force between the charges, and then we have got two parts. So we want to find out what happens to the force between the charges. Both R and Q are tripled, keeping the small q same. So let's first write down the formula for Coulombs force or electrostatic force, which is K Q1 Q2 over R square, in this case capital Q small q over R square. So that's the formula for Coulombs force for this particular diagram. Now it says both R and Q are tripled, means R becomes 3 times R, and Q, capital Q, is also tripled, so that also becomes 3 times Q. So our new force, so let's write down the new force, F new will be K, instead of capital Q I'll write 3Q because it is tripled, small q remains the same, over R square. So the R has also been tripled, so we will write 3R whole square. Now we can write this as K, I'm just going to simplify, Q over 3 square will give you 9, and R, there is a square, yes, the square is for both 3 and R, so R will be written as R square. Now this 3 and this 9 we can cancel out. 3 times 3 gives you 9, so you'll get this as 3 in the denominator. So let's just try to rearrange and write it properly to visualize what happened to the new force. So we have got K Q, capital Q, small q over 3R square. So we can see that KQR square, that was our original force, which we can see here, and we have got a 3 extra in the denominator. That means the new force has become 1/3 of the original force, so it has decreased. The next one, both charges Q and capital Q, both the charges are doubled and the distance is reduced by half. So everything is going to change here. So let's just write down what are they saying. So Q is doubled, so it becomes 2Q. Capital Q is also doubled, so that also becomes 2Q, and the distance R is made half, so that becomes R over 2. So now in this case, if I write the new force, F new, let's write it. We'll write K, capital Q is 2Q, small q is 2Q, and over the distance is R over 2 whole square. So let's just simplify it. It will become K 2 times 2, this 2 and this 2, 2 times 2 will give you 4, capital Q small q over. Now R over 2 whole square, we'll write it as R square over 4. Now what you can do is you can use mathematics, like the knowledge of math, and know that this 4 will go on the top and it will get multiplied with the 4 which is on the top, which will become 16 K Q Q over R square. Okay, or what we can do is, if we don't remember that, then we can see that I'm going to just highlight the numbers which we have got here. We have got 4, and then here I have got 1 over 4. So this is 4, and R square, I can write here a number 1, it doesn't matter. So that means it is 1 over 4. So in the calculator, what you can do is 4 divided by 1 over 4. If you do that, you are going to get the number 16. So again is the same number which we have got here, 16. So what do we see? The new force has increased 16 times. So the new force, I can write it here, F new is 16 times the original force.